All right, let's fix it. What you set up in the doodle, this December 14, 15 or 18, this is unfortunately not valid. This was for the option when you can come in. Yes, enroll me in this course. Yes, if you are not enrolled, you should enroll yourself. Right now it seems on 11th of December you can't come in. So therefore we will write the test 2 next Thursday from 14. You can be at home. Just be sure you registered in the Moodle, and if you are in the Moodle, I can give you a test. You write it, save it, and it's ready. The final exam will be also online, and it will be also in the Moodle. We can forget this doodle voting system. Yes, it's cancelled, since it based on the fact, on the assumption that you can come to the university and you can come to write here on a paper, but you can't. No way. So this is 0% chance for that. You will write it online. You will stay at home. Should we register for what? You should register for the Moodle. The links just roll up in the Discord and you will see there is one course for chemical engineer and chemistry and one course for the electric engineers. I've set up that enrollment key is physics 1 underscore 2020. But technically, it should enroll yourself automatically since I imported your data from the Neptune. This Moodle course is connected with the Neptune, so if you log in, you can enroll yourself if you are in the Neptune, and I'm pretty sure you are in the Neptune. It's up to you. I mean, you can write even at 2 p.m. Or I can set up an interval and also a time for writing it, and if it's from 2 p.m. to 6 p.m. and if I give you 1 hour to write it, you can start at 2, 3, 4, 5 p.m. You will have enough time to write it. Yes, let's forget this doodle. It was for the assumption that you can come to the uni what you want. All right. There will be 2 examples. One is this seesaw example. Oops. This is the axis of the rotation. I put one mass here and another mass here, mass 2, at the position R1 and the position R2. The question is simple. What is the condition for balance? This is the sum of the torque, which is the moment of inertia. Yes, right now we are talking about the questions for the test 2. You will find exactly these examples in the test. So equilibrium means alpha equals 0. This is the balance. What does it mean? If this part is 0, it should be also 0. How can we calculate the tau, so the torque? We have only weight, G1 here and G2 here. The torque from the G1 is R1 cross G1. But since here we have 90%, we can forget the torque as vector. The torque is simple R1 G1. What is torque 2? Same story, torque 2 will be R2 G2. But if we choose a positive direction, which is out of the screen, this will be positive and this will be negative. So this is what I write here. The condition for the balance is the 2 torques has to be equal. But don't forget, one torque will go this direction, the other torque will go this direction. What is torque 2 equal torque 1? In this special case, when this is 90% and axis of rotation is here, this is nothing else, just R1 G1 equal R2 G2. This is R1 M1 times G. This is R2 M2 G. So for example, if M1 is 2 kilogram, is R1 is 1.5 meter. If M2 equals 3 kilogram, can you calculate what is R2? How many meter is that? That's pretty simple. No need to use any calculator. You can calculate by hand also. I wait 2 minutes to solve it. And what is tau 1 and tau 2? What is tau 1 and tau 2? What are the torque, the nominal value of the torque? $30, yes. Alright, so that's the easy. Let's open a new one. Yes, one is, you are absolutely correct. If we chose the positive direction like this, tau 1 is 30 Newton meter, tau 2 is minus 30 Newton meter. Let's solve this one. Have we solved this example last week? The pure rolling? Do you remember? All right. We have a cylinder. It's important because we know for the cylinder the moments of inertia is 1/2 m r square, and we know we have three equations. The first equation is nothing else, just F equal m times a. Let's say we pull the cylinder through a force, with a force through the x of the origin, and since this is not a frictionless surface, we have some mu, and therefore we have some static friction, let's call it T. We have m, mass of the cylinder, radius of the cylinder. The Newton's second law for translation, which said the net force on the body will determine the acceleration, looks like another positive direction is to your right. F time minus t equal m times a. So this is the equation number 1. What is the rotational form of this dynamic equation? So the sum of the torque will determine the angular acceleration via the moment of inertia. We have to realize that this F force, since it goes through the axis of the rotation, so the torque is force times level arm. The level arm is the distance between axis of the rotation and the line of action, which is that just extend the vector of the force. If I put the force here, exactly that goes through the axis of the rotation, since the d is 0, the torque from this force is 0. So the only force can rotate the body is the friction, the static friction. What is the level arm of the static friction? This is the level arm, the distance between force and the axis of the rotation, and this is exactly the radius. So the net torque is T times R, which is equal to mr square alpha. This is the second equation. And like the incline example, let's assume something. So let's assume that this is a pure rolling. You can read out pure rolling in my PDF. It means the acceleration, which point? The pure rolling or from the torque? Second equation, all right. There is a so-called, page 129, there is a so-called rotational form of Newton's second law. Newton's second law is this one. Its rotational form is the net torque will be equal to moments of inertia times angular acceleration. This is how we rotate the bodies. So this is just an axiom like Newton's second axiom, but not for translation like here, but for rotation. And since the torque is F times level arm, then level arm is the distance between the force and the axis of the rotation. If the axis of the rotation, if the force go go through the axis of the rotation, the level arm is 0, so this force won't rotate. You can try, pick up the wheel of your bicycle and try to rotate via any force of the axis. You can't. You have to go out of the axis of the rotation to rotate any wheel. So the only force can rotate this body is the friction, and its level arm is R. So this is the fact that the only force that rotates is the friction and rotates by the level arm R. This 1 over mr square is the moments of inertia of a cylinder, and alpha, just alpha here. Is it clear now? All right. So these are two equations comes from the Newton's second law for translation and rotation. But here we have one unknown t, one unknown a, and one unknown alpha. So two equations for three unknown is not enough. We have to assume something. At the end, we have to validate this assumption. For pure rolling, this is how the wheel of the bicycle rotates on a dry road. The angular acceleration and the acceleration is connected by the radius. You can see some. So like the velocity of one point is r times omega. The acceleration is r times alpha. So if we know if there is a pure rolling and if we know how fast, how large is the acceleration, we can calculate the angular acceleration. These are not independent values, these are connected by r. But this is an assumption. Only assumption have to validate at the end. And this is the third equation. So here we have 1, 2, 3 equation and 3 unknown. Let's stop here, just give some dummy number like 100 Newton. M is 20 kilogram. R is 0.5 meter. And mu is 0.8. Let's calculate what will be the A, alpha and T for this pure rolling. So once again, F minus T equal M times A, T times R equal 1 over 2M. Instead of R square, let me write R times alpha. Why? Because we know R times alpha is A, so this part is A. There is R on the left, R on the right, so therefore we can simplify this equation by T equal 1 over 2MA. Let's write this result into here. F minus 1 over 2MA equal MA. F equal 3 over 2 MA. Since F is 100 equal 3 over 2 20 A. Finally, here we have only one equation and one unknown. So till this point we weren't able to solve it, but here we can have at least one result. This is 3.3. I solved it 3 times today, so I know it. This is 3.3. What can we know? A equal R times alpha. Using this equation, we can calculate alpha. That will be 6.6, 1 over S squared. And since we know T equal 1 over 2 MA, T will be 33.3 Newton. We can't buy this result until we do not validate this assumption, because all this process based on the assumption that this is a pure rolling. What is pure rolling? Pure rolling is nothing else, and this is the key point of this example. Pure rolling, if you look at a wheel, if this is a pure rolling, means the touching point of the wheel and the road is fixed. It's a static friction. And the static friction has the condition static friction can't be larger than mu times. In this case, the perpendicular force is the weight. So is it true mu times g? The g is 200, the mu is 0.8, so this is 160 Newton. Is it true that 33.3 is smaller than 160 Newton? Yes. If yes, this assumption is true, so we finished it, and these are the results. So pure rolling is nothing else, just having static friction between the cylinder and the rod. And the non-pure rolling means the friction can't be large enough to rotate the system. But you can check it. I add some example here. So for example, if we go down with the mu, means like this is an icy road, that will be a non-pure rolling. You can imagine if you start to ride a bicycle on an icy road, you rotate your wheel, that's rotate right crazy, but you stay in the same position. That means the acceleration and the angular acceleration, they are not connected by the R. So you will find these two example in the test too. Now you can have questions. These are 3 equations, 3 unknown, plus 1 condition check at the end. I think it's something you can, as university student, you can solve it. I won't go for the non-pure rolling, you can check it in the PDF, but you will solve this kind of pure rolling, but you have to check it at the end whether it's really pure rolling, because there can be typo, and if it's not pure rolling, the situation is different. Do you want to calculate it for the non-pure rolling also? Perhaps it's worth to play with. So the same, just mu equal 0.1. All right, so we are here, so we are just here assuming something. We have 3 results, and now let's try to validate. Is it true that 33.3 smaller equal than 0.1 times 200, which is 20? Oh, of course not. What does it mean? This is non-pure rolling. That means the A not equal to r times alpha. They are independent. But since this is non-pure rolling, T is not a static friction, but a kinetic friction. Imagine again, car on the icy road. In this case, the touching point of the wheel and the road is not fixed. They move it, and this is the kinetic friction. But we know, in the case of kinetic friction, we don't have to play this whole game, whether it's small or equal and so on. It just equal to mu times g, which means the kinetic friction here is 20. How can it help us? The first two equations, they are axioms, so they are always true. The only question was here, this A equal R times alpha, and we can validate it by the condition of the static friction. But if we know this is a kinetic friction, look, equation 1, F minus T equal M times A, 100 minus 20 equal 20 times A. It's 80, it's 20A. A is 4 meter per s square. What does it mean? I don't have to wait to calculate the T to know the acceleration, because this is one equation, one unknown. And also for the second, T times R equal 1 over 2 mr square alpha. Oops. 20 times 0.5 equal 1 over 2 20 times 0.5 times 0.5 times alpha. All right. This one times 2, this is 1 equals 0.25 times alpha. This is 0.25. Alpha equal 4, 1 over s square. Look, in the original situation, A equal R, which is 0.5 times alpha. So if A is 3, alpha is 6. But here, A and alpha, these are not connected by this R. So that right now the nominal value is fortunately 4 and 4. But based on the mu, if you imagine right now it's 0.1, if it's 0.01, it's only 10. Alpha will be 4.5 and A will be 4.5 and alpha will be 2. So these are two independent numbers. They are not connected via R. And right now we finish. So if you realize that this is a non-pure rolling, you also have results like 24, 4. If it's pure rolling, you will have different results. So based on the mu, based on the fact whether it's a pure or non-pure rolling, you will have two different ways to solve it. If you prove that this is a pure rolling by this calculation, you are ready. If you fail by this validation, you have to start it again, and you will have some, of course, different values. Is it clear enough? But on the PDF you can see the same solution with different numbers. By the way, this is also a lecture, so we should go through the possible questions for the exam. I've started to collect it. Give me 1 second. If we go through the topics we covered, we started with coordinate system, of course units. Yes, you will find these two questions for the test too. So let's go through the questions, because if you are okay with that, I will create a exam where you will see these questions and you can answer. So we do the final test if we have 2 marks. Yes, I think that's true. There will be 2 tests at the seminars and 1 exam in the in-depth season. You will have some grade. Some of you need only a signature, not a grade. Yes, that means you can rewrite any of the tests, but right now it's not true. You will rewrite the test later. At first, let's finish the test too. So after you have the grades for test 1 and test 2, and if it's passed, you can register for the exam. At first, let's solve the main problems. Write the test 2. If you do your homework and if it's okay, I can forget the test 1. So please try to solve the homework I gave you last time or 2 weeks ago, and if it's okay, I don't want to hurt you by rewriting the test 1. There was homework for the lecture. But at first, really just concentrate on test 2 because this is the most urgent one. I think yes. Let me check what I don't I, I, I don't understand. So after test 2, I mean if you have test 1 and you will write a test 2, your seminar is okay. You will have a grade and you can go for the exam. Yes, that's true. And it seems to me, at least in December, but I'm pretty sure also in January, the test will be also online. So you will see a test in the Moodle, a question you will answer, and this is how you will get the grade. Yes, exam. Wait, I can save it and send it to you. These are the questions, but right now you should check it whether you are okay with that or not. Open it, check it. 5, 10 questions, so depending on the complexity of the questions. Exactly. Please check it. I have too many groups, and that was okay for one group. I think we did it parallel. Uh, if you find any unknown question here, let me know, because during the weekend I will create the catalog for the questions, and on the exam you will see these questions. I do not worry about late submit. If you can submit, just submit it. Do not worry about it. I don't know right now the answer, what's happened. Yes, so if you go up in the Discord link, I've sent the link. Physics for engineers is for chemical engineers and chemistry, and physics 1 is for electric engineers. I set up to pick up the students from the Neptune, but since I add the uh, enrollment key, you can enroll as chemical engineer for the physics 1 and upside down and vice versa. So be sure you find the right Moodle group. Somebody should go through these questions, because if you don't check it, and I don't want to have any surprise during the exam? No. Final exam you will find in Neptune, but you can't register since you don't have the grade for test 2. Final exam, check the Neptune. I I created the exams. Wow. If you registered, does it mean that you had the grade for seminar or the signature for seminar? Because without seminar, I don't know how can you register for the exam. If you had the grade for seminar, it's okay. But for the ones, yes. Test 2 is for solving these examples. Exam is answering the questions. Yes, technically, no, I really want to ask somebody to check these questions because if you don't check it, that will goes to the exam. Or if you've checked it and you say you are okay with these questions, you can go. I'm pretty sure that the exams in December will be online, but almost sure that the exams in January will be also online. 10%. Yes, these are topics. What does it mean? For example, static friction. Look, static friction. You will see this question or topic. You should tell the story about this one. Since we have two bodies, the surface and the body, we don't know, we try to push it, but it does not move. That means the friction can be enough to compensate the force. This is the static friction. After a given force, like here, this trash bin starts to move. This is the kinetic region. So read it and you should tell it with your words. What is static friction? Static friction is something I tried to move somebody. Yes, I got 30. So I don't want to see the copy paste of this of my PDF. You do not do that. Try to say with your words. I mean, circular motion, this parameter, and this is the slide. So if we know angular acceleration is pi over 2 and there is initial omega and initial theta, we can calculate. But alright. But describing circular motion, this is this slide. So what is theta, omega, angular acceleration, and so on. Oh, if you got it, then let's go back. I save it before I forget. Check the Neptune. There are at least 5 different time for exams. Yes, it seems. Alright, so I've sent the questions. Since next time we will write the test 2, since the test 2 is online, you will have the result pretty soon. I will correct it and you will have the grade and you will come for the exam. No, it's not exactly. So the test 2 is really a test. So you open like a form or a web page, you will see a question and you will see a field where you can write that this is 100. And if you submit it, it will save it and you won't be able to go back to correct it. But the form will be like it will be in the Moodle. Perhaps you have you ever write any e-learning test? I don't know the others, but this is like really a form on the web. What is the A? And if you write in the field of A3, and if you save it, if it's correct, you will get the point. If not, you won't. So you have to calculate correctly. Otherwise, I won't be able to see where you failed. Wait a bit. Do you see it? Sorry, it's Hungarian, but it will be like this. This is the third question. Calculate this one. And if you write here, this is 3. And you can go to the next one. This is 4. This is 5. I won't add like this. And this is 6. This is 8. This is some answer. This is 5. It's saved. And you can submit and finish it. And you will see, since these were not correct, I got 0, I think, for this test. So you write something, you go through, and at the end you can submit, and you will get, let's say, 1 hour for that. So this is the philosophy of this test. Question, you can answer here. Next one, next one, next one. But for the test 2, it's only 2, but you have to answer the, let's say, R2, the T, A, and alpha. So you will see 4 fields, you have to fill it correctly. This is just the example I showed you. So you will write in the white place numbers and save it, and this is the test. For the exam, you will write text in the white field. I don't know what is MCQ. No, just the answer. Yes, more or less. So you won't see multiple choice questions because you don't have to choose, let's say, A is t equal 10, B is t equal 20, and so on. You have to write that this is 10. It's not MCQ. All right, if there is no more questions, oh, I see another one. Yes, check these topics.